question always arises is that we use the orthogonality component, the technology, in other areas than vector and calculus. Can we use the concept of orthogonality in design principle? So, can we use the concept of orthogonality while doing the design? So, that is the concept that we will see. Okay, so we have what we saw that if two areas, one is vector and other is calculus, vector, calculus. In vector, if I have a vector, then vector can be represented using three orthogonal components, that is along I-axis, J-axis and K-axis. So whatever the manipulation, whatever the mathematics we do on vector, that can be done instead on the orthogonal components or independent variables, independent components. So this is what we see, we saw, and dot product and cross product. Rather than doing A cos B cos theta A or B sin theta A, we went for all the computation through orthogonal components. Okay, like A1 B1 plus A2 B2 plus A3 B3, or or A or A2 B3 minus A2 B3 minus A3 B2, like this is the I component, or J component A1 A3 minus A3 B1. Okay, and K component would be, okay, so K component would be A1 A2 and minus B1 B2. So we saw that dot product and cross product, rather than going through traditional vector computation, we did it through component based calculation. So component based calculation is nice. Like if I have in machine learning, if I have a set of features, set of feature means set of attributes, and the samples means instances. So if I have a class and it has set of attributes, for one set of attributes, then it is called one instance. One instance is one sample. So in a data set, if there are, for a particular class, if there are 20 samples, then there are 20 instances. For each instance, the value of set of attributes are different. So attributes are nothing but features. So feature contains the information. Now suppose that I have kind of 1000 features. So each sample has 1000 information. But information may not be orthogonal to each other. In that sense, can we have only n number of features? Okay, the number of features only n in number, then n would be very less, 2, 3, 4, 5, 6, 7, rather than 1000. So full information what is contained by 1000 features would come in some 6 7 features, but 6 7 features should be orthogonal to each other. If they are orthogonal to each other, they don't have any intersection, they don't have anything in common. In that way, it will contain all the information. So in machine learning, like we go for dimension reducibility, dimension reductionability. In that way, we calculate the Ein vector. So Ein vector is nothing but set of vectors, okay, kind of orthogonals, and they contain the region of the maximum variance. So if I have a data set and I have feature value, then feature values are varying maximum along what all the axes. So that is one way that we calculate the kind of orthogonal component. Like if there is a child, then it has weight, it has height, and it has knowledge. So a child is represented using weight, height, and knowledge. All three are orthogonal to each other. So orthogonal in a sense that if I increase one variable, if I increase one variable, or I mean if I make changes in one variable, other should be unchanged, untouched. So that is the scenario. So if I say that if a child has a weight, then it is independent of height and knowledge. So weight can grow, weight can be lessened. So in that way, it is like it is independent of height. If height is growing, not required that his weight and knowledge would grow. Or if he is gaining the knowledge, not required that his height and weight would grow. But if I see the age, then age is dependent upon all three. Because if height grows, means age is growing. Age cannot reduce if height is growing. If weight is growing, age would grow because time it will take. If knowledge is growing, age is growing. So age is dependent upon all three, whereas these three are orthogonal to each other. They are not dependent upon each other. So they contain the maximum information. Everywhere, science of orthogonal component is precious than platinum stone, platinum gem, we can say, or diamond gem. Okay, but what diamond is very good, very nice, so glittering and shining and so good. Then why we don't wear diamond? I don't. Why we don't wear means not the male. Why the ladies or female, whoever we see, they don't wear the diamond. Answer is straightforward. Diamond is very precious. In the precious in the sense that it is difficult, very difficult to find out. If you find the diamond also, then I have seen the kind of video, uh, Hir, Hirni or Mirni, a diamond mine that used to be in Siberia region of Russia. Okay, I believe it is Hirni or Mirani. Okay, and it is not easy to take out the diamond. Means diamond generally they are found inside stones. So if you kind of somehow if you break the stone, the inside the stone diamond will be there. So it is we don't know which stone has diamond inside or not. So it is a tedious process to first finding the mines where the deposition of the diamond is there. That is difficult, and then taking out the diamond is very difficult. So it's not easy. Like that, the if we have any class there and it has lot of it like color. Color is a class which contains the color. So color for if I have 20 million colors, then for 20 million different kind of full data structure I have to make so that all colors should be different. If one color is different from other, then if there are 20 million color I have to keep in the data structure. So that way we have to assign the memory. But all colors are can be represented in red, green, and blue. So we need only three variable red, green, and blue. All the color will come under red, green. But concept of finding the orthogonal component is difficult. It's not that straightforward. The way it looks, like the wearing diamond is very good, but finding diamond is very difficult. Like that. So we can kind of extend the concept of orthogonal component. It is nice in designing area. Okay, like if we see designing principle. Okay, SOLID, single responsibility, open close, Liskov substitution, interface segregation, and dependency inversion. So five design principles are there, whereas we have around five creational design patterns. Seven, we have a structural design pattern, and 11 we have behavioral design pattern. So 23 design pattern. Can we bring the concept? So am repeatedly saying whatever we are talking during these videos, it's not available in any book. You can kind of find out anywhere. So whatever we are talking, so all we are filing disclosure. So now if I talk about the orthogonality in designing, like open close principle, okay, sorry, solid, S means single responsibility principle. A class should carry single responsibility. Okay, there should be only one reason that class should change. That is the another way we can talk about the single responsibility principle. Like there is a class, favorite class called printer. Printer is a class which accepts the document. Okay, there is a communication module that printer has. Someone can use the communication methods and it can send the document to the printer. There is another area which prints the document. There is another area, whatever is successfully printed, it faxes it somewhere. And there is another area which does the stapling of the printed material. So four things it does. Now it has four reasons to change. This is what called in designing. Can we consider these four as four orthogonal components? Okay, this is, if this is true, then it can bring revolution in design. So now you are finding the, or in terms of machine learning or dimension reduction, we can say that there are kind of four areas where, four direction where the variance changes maximum. There is a maximum variation, otherwise there is no variation. Or in terms of design principle, there are four reasons to change. In terms of mathematics, there are four orthogonal components. If we see, okay, one is communication module which receives the document. Another is communication module which receives the document. Another is printing module which prints the document. Another is faxing module which faxes the document successfully printed. And once it is printed, then a stapling module would staple it. Now, four are orthogonal to each other. How I can say that four are orthogonal to each other? How I can find? That is the question, first of all. Now, there are two sides when any component is generally we see. One is service side. Service side means the component that are written, library side, and one is client side, that is dependent upon the component that use the component. Now, client is using printer class. So, client is using the printer class. Since it is using the printer class, everything related to communication, means sending the document, everything related to printing, everything related to faxing, and everything related to stapling, all are visible to the client, and everything is forged on it. It does use it or it does not use it, but it is getting all the four areas. So that is the one thing. Another thing, in service component where the code is written, okay, everything are messed up. Okay, if this, then communication module, this method are using. In communication module only you are checking that if communication has error or it is successful or partial successful, then go for printing and something like that. Now inside the printing you are writing that how much through communication module what you have received, and then let it go for printing, and then again search for communication module if everything has come or not. Then let's go for faxing. Inside the faxing, again you check the printing status and everything, and then you go for faxing. Then for stapling, you check all the modules prior, the things were nice and what has been done. Then you go for stapling. Everything is missed, unnecessary. So this is something that even though it is orthogonal, but we are making meshing up. Now, if we say that I have four different classes, if we say then I have four different classes, then boss, if you have four different classes, then there is a chances, means four different classes in the sense that four different a kind of four, there are different reasons in which the class would change in designing term. In machine learning term, there are four directions of the variance. In variance, if I see the direction of the variance, then there are four directions. In mathematics, there are four orthogonal components. Orthogonal means they are at 90 degrees, means they are different to each other. Okay, if there are four reasons to change, then why don't we put in four different classes? That is single responsibility. Each class should carry single responsibility. Each class should be independent to others. If they are independent to others, then if I make any change in communication module, if I make any change in print module, if I make any change in faxing module, if I make any change in stapling module, if that is the case, then no other module should be touched. That is the scenario. All modules should be untouched when any of the service class is changing. So printing class, printer class. Now printer class has four different responsibility. It has four direction in which there is variance, or it has four independent variable. It has four orthogonal components. These four are new four classes now. One is communication module, print module, fax module, and staple module. Now, idea is if I know that there are four reasons to change, then how we can be assured that there are four orthogonal components? So that is the question. Now, in the service component side, the idea is that if I have identified the four reasons, then inside the methods of all four different classes, okay, if I make in all methods, if I make any change anywhere, other three class methods should not be affected. Okay, so every part of the communication module, every part of the communication, every method or every logic or every set of execution unit, every set of code unit, if I go and make modification, okay, other three class methods, print, fax, and staple, it should not be touched. They should not get modified. There should not be any change seen. If there is any change seen, either it is not orthogonal or orthogonality is not correctly implemented. Okay, so if we are able to come to a level where all four are completely independent to each other, in a sense that their code, what we make change in the code anywhere, it is that change is not propagated to any other module, any other class method. If that is the strict scenario that is seen in the client component, then all four classes are orthogonal to each other. So this is one scenario that we are seeing in open close principle. We are seeing in the single responsibility principle, as far as bisecting or intersecting or multisecting the class into orthogonal components. Now see the client side. Client side was using printer class earlier. So client side, now instead of printer class, it is using four classes: print, communication, and then stapling and faxing. Now there can be scenario where it does not need print, only communication and fax. Possible. It will send the document to the printer and request to fax it, because it is printer cum faxing machine. So then he should not be dependent upon the print and staple class at all. So he can just set it to null. I mean, set it to null in C++ or none in Python. Now, the client component, he would use only the communication and fax classes. Other two classes, he can set it to mute, null, not instant, no need to instantiate. If that is the case, then if client component is dependent upon faxing and communication, he is not forced, he is not forced to use the other two classes. If that is the scenario, that whatever the client is using, that is okay, but he is not to use the methods of other classes, then classes can be said independent to each other. So component side, the service component, we saw how it is independent to each other. Making changes anywhere should not be reflected, should not be propagated into other class methods. If that is the case, no one is dependent upon each other. I mean, they are independent, they are orthogonal. And in client side, if there are four orthogonal components, then I should be free to use only one, two, three, or all four, either of them or all or whatever, any combination. And in that way, one one set of methods in a class. So client who is dependent upon one particular class, he should not see, he should not be forced to see the method of other class. So this is if it is satisfying in the client side. If it is satisfying in the component side, if both satisfactions are happening, then it can be said that it is orthogonal to it. So all four components what we talked, that print and communication, print, communication, and then staple and faxing. So all four are proved orthogonal to each other from the client side and from the service side. Okay, so we'll continue on this discussion. So we talked about making a class orthogonal. Means we had printer class, no more printer class. Means printer class is now, it is distributed in four orthogonal components, and client side and service side both are using now, both are kind of they are happy with the orthogonal. So whatever the load, like if I have made a house, small house, okay, it is made of the wall, and wall is made of the brick, and there are 1000 brick, one small room. Then the roof, full weight of the roof is falling on all the bricks. So there are 1000 bricks. There are 1000 kind of features. There are 1000 features. Now, if I place four pillars along the under the roof, then I can break the wall, not required. So now the roof is only dependent upon four pillars. Four pillar, 1000 brick. See the difference. So all four pillars are four direction, they are orthogonal to each other, they are independent to each other. In that way, if that is the case, then it is simple. Like that way, if I had a class called printer, but now four pillars have come and they are independent to each other. The client side, it he is happy because he can use any class, not three required. Or service component side, they are happy, changing anywhere it not propagated anywhere else. So someone can pinpoint the error in the component, or any modification, any enhancement is happening, he would go in that particular method, he would do the enhancement knowing that it is not going to do any difference in other classes method. So means so clean cut, right? It is kind of open for extensibility and closed for modification. So it is like that. So nice. So we'll see that now instead of orthogonal component as classes, how better it would be if it is kind of interfacing. So that we will kind of propagate on.